Okay, word problems 2, everybody's favorite. So I want to tell you guys, or remind you guys, there's an exception to this. You might like it better. This is actually 2 variables. And what are the variables? X and Y. They don't have to be, but we're going to start off that way. Okay? So you're going to get word problems again, this time with 2 variables. So it's even better, even nicer. Because, you know, the things that we studied here, solving systems, weren't because you have nothing better to do than to solve some systems. They're for a reason. They help you get answers. Okay? And they actually have a lot of applications that you guys will see here in other math classes. Even in your science courses. Okay? So you want to be familiar with these concepts. They're very powerful concepts. So I'm going to start again with some of the ones that we worked with in the past. So for example, this is going to be number 1 in the worksheet titled Word Problems 2. Okay, Word Problems 2. So I gave my sheet again to the older gentleman that I just walked out of the room. He sits here. So I'm going to have to read it off my phone. The sum of 2 angles is 146. I'm going to say the sum of 2 angles is 146 degrees. One angle is 28 degrees less than twice the other. Okay? So here we go. Notice the first phrase says what? The sum of what? 2 angles, okay? So why do you think we call this word problems with 2 variables?
X, Y.
Yeah, we're going to say x is going to be what? We're going to let x be, well, let x be 1 angle. And then y be what? The other angle. Because in the second sentence, if you notice this, they use they refer to the angles as 1 and what? The other. You with me on that? So I want to let x be 1 angle, y be the other angle. What does it mean to talk about the sum of the 2 angles? What does sum mean? To add. What are the angles? X and y. What is it supposed to equal? Is 146. So if we put this together, we get x plus y equals 146. Okay, you okay with that first one? Everybody okay with this first sentence here? This means the sum of the 2 angles, you call them x and y, is 146. Is that pretty simple? What does the second phrase say? 1 angle is, what do we call 1 angle? X. So this is x. How do we describe is? Equals 28 degrees less than, I got to think of this. Did I have a triangle less than rectangle phrase under my belt? Yes, I do. What is that? What does less than mean again? Isn't that subtraction? But less than, if you guys remember, is what's going on. If I write this as x is, short for is equal, less than what's subtraction? Here's subtraction. What do we do with the triangle and the rectangle? You switch it. Is that true? So, because it's less than, we switch this. That means 28 is on the right. Even though I read it on the left, we switch it. Twice. Oh, what does twice mean?
2 times.
2 times. Good. 2 times what? Y, because that's the other. So, ladies and gentlemen, this will be 2y here because we have to switch it because of the phrase less than. So, go back and remember, these phrases were your best friends. Okay? Does anybody have any questions on the translation here? What do you guys notice here? What are you looking at? We're looking at two equations. First, second, two unknowns. X, what? Y. X, Y. You guys okay with that? Now, they should have said here to you, here's going to be the last phrase. They're going to say, what are the angles? So, I'm not going to spend the day today going over how to solve these systems anymore. Because what have you guys had? You had the graphing method. You have what? Substitution method. What else? Elimination method. You got three methods. When they ask you for the angles, they don't tell you what method to use. So you are free to choose your what? Choose your poison. Do you want graph? Probably not. I wouldn't graph it. I don't, because graphing means my y-intercept for my first equation is 146. My graph paper probably doesn't go up to 146. So I'm going to use either probably substitution or what? Elimination. Does that make sense? So what would you guys use for this scenario? Good. So you're going to use substitution. That's right. So I'll do the first one here for you guys today. So we could go through the process. You guys can see how this works. I want to set this up for you guys so you could go home setting up your word problems. And by the way, on a test, how do I grade that, right? I'm going to look for the first phrase. Do you have the first phrase? Hopefully. Do you have the second phrase? Hopefully. Do you have the answers? Hopefully. So a big part is for you to set that up, meaning you got to read it and translate this. So, all right, the second equation is x equals 2y minus 28. So tell me, what do you guys do now? If you worked on the homework last night, and it was what? Solve the system by substitution, we're substituting one equation into the other. I'm going to substitute what? Second into the first by what variable? X. Good, because this is x is, remember? X is this thing. So wherever there's an x up here, replace it with the 2y minus what? 28. Now what do you get when you do that? You get what? 2y minus 28 plus y. What does that equal? 146. So if you combine your like terms, what's 2y plus y? Remember, this point, don't you solve for y? Okay, you're going to solve for y at this point. We get what? 3y minus 28 will be 146. Translate my 28. On the other side, it's positive. So you get 3y is 146 plus my 28. You know what 146 plus 28 is? Is that 174? Okay. Divide both sides by 3. Boy, I don't know about you. I think I'm an expert in solving equations by now. What's 174 divided by 3? Is that 58? Is that 58? Yeah. I think you're right. You found the y value. You say, well, how do I get the x value? What do we use? Back substitution. You plug back, y is what? 58 into which one? Any of them. What am I going to probably use? The second one. You say, why would I use the second one? Because it's already solved for what? It's already solved for x. So this is going to be now x equals 2 times 58 now, right? Minus the 28. So what's 2?
Is that decimal or?
No, it ain't. It's 2 times.
Oh.
So what's 2 times 58? Is that 116? X will be 116 minus 28. What's 116 minus 28? What is it? 88. So x will be 88, and y will be what? 58. So 88 is one angle and 58 is the other angle. This is why you guys learn the methods of solving a system, because you're going to use this in sort of kind of real life. Okay? These have real applications for you. So it's a fundamental scheme here of how to solve for two variables given two equations. All right? Anybody have any questions on this first one? So remember, I'm not going to want to go through how to solve the systems anymore. I'm going to want to go through how to set up your word problems now. Okay? And then you guys are going to be good to go, and you know, you're going to work on those problems this weekend, and you're not going to wait till the night before a test to start to do homework. Right? We talked about that already. Can I erase this? Anybody have any questions?
Actually, I have a question.
Yeah.
Okay, right there it says the 20 degrees less than, and you know how you did the triangle and the rectangle? Every time it says less than, is that always going to be like the triangle, rectangle thing? And
Yes. It switches for less than and for what? More than.
so for both situations, it'll be the same thing?
Well, addition will be the operation for more than. But the point is it does switch. Don't put it on Facebook. I guess it doesn't really matter, right? All right, can I erase this here? Anyway, this is number 1 on the worksheet. Let's do number 3. Okay, so remember, we're working on word problems with two variables now. I got to read it from my phone because I gave it to a good friend of mine. The two angles are supplementary. One is 40 degrees more than 3 times the other. So this is now number 3. Two angles are supplementary. One angle is 40 degrees more than, was it twice or 3 times? 3 times the other. And then they're going to say, what are the angles? So that's pretty much solved the system. All right, here we go. Okay, so there's two angles again. What are you going to call them? X and Y. So I'm going to say, let X be one angle, and Y will be the what? The other angle. So if X is one angle, Y is the other angle. What does it mean if they are the two angles being X and Y? What does it mean that they are supplementary? What does supplementary mean? Well, what is 180? The sum is what? 180 degrees. So if your sum is 180 degrees, what does that first statement say about X and Y? What does it say? That X plus Y equals what? 180. Okay? You guys okay with this? Anybody have any questions on this one? All right, look at the second statement. What does the second statement say? One angle is. Is code for what? Equals. What did we call one angle? X. Everybody okay with that? So X is the one angle here. That means X equals, for the second equation, X equals, what does it equal? 40 degrees. Uh-oh. Let's write it down. I see a more than, I see a triangle more than a rectangle phrase. What do you guys know about this? What does more than mean? Plus, it means to add. Is that right? You're going to add here. But what did we just get through saying? That they switch. Now you say, well, what do you mean? Well, I'm going to write down the rectangle plus my triangle. Now, in my triangle, what do I know is there? 40. 40 is here. What does 3 times mean? It means 3 times. 3 times what? The other. What do we call the other?
Y.
Y. Good. This is y. So this will be 3y. So what I'm showing you here is a what? Here's a system. When they say, what are the angles? What are you guys going to do? Solve the what? Solve the system. What might you do? What might you think? What is going to be a good method here? Well, you guys know what I would use? What would I use? Excuse me. Yes, you're going to use what? I would use substitution personally. Do you have to? No. Could you do it by graphing? Yes, I wouldn't, though. Why? You got a y-intercept of 180. You probably don't have that many columns. Okay? So I use substitution or elimination. It's now up to you. You have freedom. Somebody had a question back there?
How did you pick excellence of one angle?
That's a very good question. You know when you read this and it says 1 angle, yada yada? That's a very good question. I just read it first. So if I'm talking about 2 angles being x and y, and it says 1 angle, well, I'm just going to say, well, let that one be what? 1, because I'm reading it first, is 4 times the other. Oh, if this x is 1, then y has to be the what? The other. Does it matter if I switch those? No. So I just wrote it down that way because that's how I read it from left to right. Okay, but yes, exactly. That's how you do it. Okay, everybody okay with this? Is it hard? It's hard. Why is that? Because there's something that people hate more than math. Huh? Not word pro. There's something that people hate more than math. What do you think that is?
Arithmetic.
Words. Words. People hate words more than what?
Math.
More than math. Some people sign up for math classes because they're really trying to avoid the what? The words. They go, isn't math just symbols? People rather just look at the symbols. Do you guys know that? I know that. Anybody here because you avoided the words? And then all of a sudden they go, darn, there's words here too? Yeah, you can learn a lot of language in mathematics, a lot of critical thinking. So, I mean, I kind of think it's a very important thing that, that gets overlooked is the language component in mathematics. Okay? Question? No? The language component in mathematics. Very much overlooked. People kind of just think that, oh, math is just number crunching. No, it isn't. There's a lot more to it. There's concepts to be familiar with. There's phrases and words you have to deal with. Complementary, supplementary angles, right? We're going to look at another one, number 5. That's a complementary angle. There's concepts to understand and work with, words to be around. So all of it together makes something pretty significant. So anyway, you don't want to shy away from math and English. Right? Didn't I ask you guys plan on having kids? You guys planning on having kids? Huh? What do you think? You're gonna what? What kind of grades? What kind of subjects do you want to actually make sure your kids do good in? The 3 R's. What are the 3 R's? Reading, writing, and arithmetic. I don't know why they call it an R. It's arithmetic. Reading, writing, arithmetic. 3 R's. Oh, you're right. Writing is a W. Good. I guess. 2 angles are what? Complementary. 2 angles are complementary. Twice the first angle plus the second angle. Twice the first angle plus the what? Plus the second angle is what? No, this one, number 5, is 123 degrees. So I'm going to erase this portion here because, like I said, you guys are going to solve your system. Then they're going to say, what are the angles? Yes? Yeah, 123. So I'm going to ask you, what are the angles? Okay, so what does it mean to be complementary? Anybody remember? What was that? We talked about that before. That the sum is what? Is 90 degrees. The sum of what? The two angles. So I'm going to say here, let x and y be the what? Be the angles. So when they say that they are complementary, which means that the sum is what? 90. What do you write down for the sum being 90? What does it mean for the sum to be 90? What's the sum? Addition. So you say x plus what? Y equals 90 degrees. Now let's go with your question you had. If we read the next statement, what does the next statement say? Twice the first angle plus the second angle is what? 123. Okay. So, did they ever tell you, by the way, like in the last example, which one was the one angle, which one was the other angle? Did they ever tell you that? No. They even changed the reference now. They're even saying to you, you got something called first angle, something called what? Second angle. So you got first angle and you got what? Second angle. Which one is which? Doesn't matter. That's up to you. When I read this first, second angle business, I say, okay, let x be and y be my angles. I'm going to call x my what? Why would I call that one the first? Because it's first as I read it. What about the y? I'm going to call that the second, because it's the second angle as I read it. So now what that does for me is I can now translate the statement. Twice the first means 2 times what? X. What does plus mean? Plus. What is the second? Y. What do I replace is with? Equal. What does it equal? 123. So you're going to write down now 2x plus y equals what? 123. So you have 2 equations and what? 2 unknowns. And I'm just curious, what would you guys use? What would your method be here to solve this? You might use substitution or what? Elimination. Elimination? Some people may choose elimination. You say, what do you mean? Let's do this one. We'll review this one. What do you want to multiply then the first by? -1? You could. You could do -1 or -2. Depends on what you want to eliminate. What variable do you want to eliminate? The x or the y? Okay, if you want to eliminate y, you may say what? Multiply which one? It doesn't matter. One of them by what? Right? Which one do you want to multiply by -1? Because don't you need opposite values here? Don't these have to be opposites? So what should you multiply by -1? First one? Fine. If you do that, don't you get what? Negative x minus y, what does that equal? Negative 90. And then, what about the second equation? You leave that one alone, don't you have 2x plus y equals what? 123. So, by the elimination method, also known as the addition method, you're going to add the left sides together. And then what is negative x plus 2x? X. What's negative y plus y? It's gone. That simply equals negative 90 plus what? 123. What does that give you? So x is 33. What are you going to use now? Use what? Back substitution. So by back substitution, when x is 33, you plug in 33 into which equation? Doesn't matter. You're going to now find the value of x. So if I use the first one, that means x plus 33 becomes what? 90. So what do you do with that 33 now? Translate it, and what do you get? X to be, what's 90 minus 33? Is that 57? Okay. So the first angle is 57. 57 degrees, by the way, just to point this out to you. The second angle is what again? 33 degrees. Is it true that a 57 and 33 degree angle are complementary? Yeah. When you add them, does it come out to 90? It sure does. So we did the problem right. Okay, so I did go through this addition method with you. All right, anybody have any questions? Yeah.
How'd you get 33? Yeah.
Oh, how we get 30? Well, we use the addition method. We multiplied the first by negative 1. And by the addition method, what's negative x plus 2x? X. What's negative 90 plus 123? Positive 33.
You mean y is 57?
What's that?
Y is 57.
Oh. That's right. What do we do? Hold on. Oh. It's the same thing. Okay, but let's go. Good. No more NyQuil for me. X is 33. Okay, x is 33. So go back. Replace what? 33 for x. So you should get 33 plus what? Plus y should be 90. And you're right. Translate your 33. Y will be 90 minus 33, or y is 57. So you're fine. It's still 33 and 57. Okay? Those are your two angles. Yes?
Will the question ask us to use certain process like elimination?
Not with the word problems. With the word problems, you're free to use your method of choice. But if they didn't give you a word problem, they just gave you a system, well then they may or they may not. It's kind of like that first worksheet. If you notice, or maybe some of the homework. At the end there, it says graph by any method. So if they say graph by any method, you could use your favorite. Here, for word problems, you could also use your what? Favorite. Just don't let your favorite be graphing. Why don't you let your favorite be graphing? Anybody want to tell me? Huh? Well, if you try to graph one of these, right, translate your x, your y-intercept's 90. Do you have 90 on your graph paper? You have to go up to 90 boxes for one problem. You may not find that x is 33, y is what, 57. So you have a pretty big what? You know, pretty big problem to kind of do graphically. Could you do it? Yeah, put some 5 graph papers together, or 6. Do you want to when you could simply do what? The addition method? No. That's what I'm saying. Okay, so graphing is not the most efficient approach. And in all honesty, I'm going to say to you, the reason we graph, well, we got to show you how to graph, number one. You get extra practice. But graphing is, graphing is such an important skill that even in a calculus setting, sometimes some students in the calculus setting, they forgot how to graph. Or college algebra, they forget how to graph these lines. Intermediate algebra, forget how to graph. It's not good. I mean, are people going to forget things, you think? Yeah, people are going to forget. But if you learned it to review, what could you do? You know, if you really learned it the first time, it'll come back. It's kind of like riding a bike. You read it and you go, oh yeah. All right. Do you guys know why? There's neurons that fire up in your brain when you go through this and you learn it. And they keep firing up in the same way repetitively if you keep doing, you know, the problems, different problems. So those pathways are already there fired up in your brains. So to kind of go back and retrieve it is just actually asking your brain, hey, fire up the neurons in the same exact way. And that's the process in your brain. Now, you may say to yourself, you said, is that the reason why I never really learned how to do some of these math problems is because I didn't practice? The answer is what? Yeah, you didn't practice enough. So those neurons didn't fire up that way. That's a learning process. You know? So that's true about pretty much everything. You know? So you guys want to think of it that way. It's neurons in the brain firing up. So you can retrieve it even if it's been a little while. I have an 80-year-old math student sitting in the front here.
Yeah,
In the prior class, yes. Some of you guys notice I'm seeing there?
Yeah.
The guy I give all the worksheets to all the time? You know he gets the problems right. He translates the stuff with me in class. And you may say, wow, how does that happen? He must have the math gene. No, he's firing up those neurons again. He's already learned it in the past, you know. He's just firing them up again. So, you know, we retrieve it differently at times, and, you know, it's interesting. So let's look at number 7. Is the perimeter of a rectangle is 48 meters. Remember we worked on these problems too? So the perimeter of a rectangle is 48 meters, okay? I'll leave the meters off. If the width was doubled. Uh-oh. Hold on, let me go back first. Let me do number 6. We'll do 6 before 7. Perimeter is 48. One side is 12 centimeters longer than the other side. Oh, no. No, we could do that one. Do you guys want to do it? Should we do 6 or 8? Oh, it doesn't matter. You want to do 8 better? Do 6 better? I don't know. I'd like to do them all. That's my problem. Should we just stay an extra hour, just do them all? No. Let's stay. We'll do double the problems. Yeah, let's see. All right, well, it doesn't. I want to give you an easier one. Let's say the length of a rectangle, the perimeter of a rectangle is 50 meters. Let's try this. Then I'm going to tell you, and I'm going to say this to you. No. The length is 5 feet longer than the width. If the length is 5 feet longer than the width, what are the dimensions? Yeah, be 50. 50 meters. 50, we'll say 50. We'll put the dimensions, 50 meters. I think we really have to. Oh, wait a minute. That'll be feet. You can't add, well, we could, but we got to keep it simple. All right, let's try this out. What kind of shape are they talking about? How do you know? Says it. Okay. And then they're using language like what? Perimeter. Is that true? So what do you guys know about a rectangle? Don't you have a what? You got a length and you have a what? Width. Is that right? Okay. So when they say perimeter, they said the perimeter here is 50 feet. So perimeter, what letter should we use? Huh? P? Okay, so my perimeter is, this is equals what? 50. But what do I know about a rectangle and the perimeter? What's the formula for the perimeter? Perimeter is 2L plus 2W. Okay, good. Does anybody know what this means logically? Anybody know? Logically, if we put these two pieces of information together. What could you logically conclude about these two statements? If P is 50 and P is 2L plus 2W, what does that mean? 2L plus 2W equals 50. Are you sure? Is everybody okay with this? If I told you going to Vegas is fun and going to Vegas is expensive, what could you conclude? We'll make it easier than that. Going to Vegas equals fun. Vegas is expensive. What does that mean? Fun is what? Expensive. You guys see what that means? That's actually what you can conclude. Some people, and I go through this, some people don't know that. They'll go, I don't know why you can say 2L plus 2W is what? 50. You know what I'm saying? So I'm doing it for them. Not for you because you know it. It's for them. Some people don't know. Going to Vegas is fun. Not really. Going to Vegas is what? Expensive. So fun is what? Expensive. Do you guys realize that? Good. Okay, that's the key here. What else do you have? That's the first sentence. What's the second sentence? Length is L equals, well, let's see. What does this mean? This means that, this is the next equation now. L equals what? The length is 5 feet longer than the width? What do you think longer than the width means? More than? Good. Maybe you want to replace that with what? More than? And what does that mean? W plus 5. Good. These are your two equations, ladies and gentlemen. That's what you guys use to solve this system. You got a system here. Two equations, two unknowns. I want to point out to you, though, notice this. This is the first time, I think, today, have all the other examples have X and Y in them? Yeah. Notice what I'm going to show you guys. Everything I've done, even with you, is X and Y. But do you have to have X and Y? No. It doesn't matter what two letters you use. The process is the same. So we're kind of in a situation where we're going to transition. Is that right? So maybe I'll do this problem too because it's a transition for you. You got different letters. Does it matter? Can we still use the substitution method? What do I mean by that? You're going to substitute the second equation into the what? First equation. How do you do that? By substitution. Let me write it down. Wherever there's an L, we replace it with what? W plus 5? So this here is 2, not times L anymore, but by what? W plus 5. Don't forget plus my 2W. That's supposed to be 50. So what I'm saying to you is this L is W plus 5. Replace this L with a W plus 5. So what you should see is 2 times W plus 5 in parentheses plus 2W equals 50. Where did I get this 2 from? This 2, the 2 up here is the same 2 down here. So I'm saying L is W plus 5. Replace that with your L. So there's a 2 times the L, 2 times W plus 5, plus my 2W is 50. So here's an equation. One equation, one variable. What do you solve for? What variable is there? Solve for the width. Okay, so you can still use this elimination process. Now, to get rid of your parentheses again, you use your distributive property. Remember that? So what's 2W? Well, 2W plus 10 plus 2W equals what? 50. What's this? 4W plus 10 equals what? 50. Translate your 10, and 4W is 50 minus 10. 4W is 40. Divide both sides by what? By 4. What do you get for W? W is 10. Now, it's going to be in feet, so 10 feet. If they said, what are the dimensions, they don't just want the width. They also want the what? The length. So, how do you get the length when you're given the width? Plug W back in where? Where's my equations? It's right here. These two. Want to do the second? Why would you do the second? Because then L is going to be what? 10 plus 5. What's 10 plus 5? So you could say the length is what? 15 feet. Okay, there you go. I wanted to try to warm up to the next one. Number 7. I'm just curious. Let's see. If you guys noticed that we actually did these before. Do you guys know? Remember? We did all these, but we used a single variable x for everything. So you can use either a single variable to do these problems, or you can use 2 variables because there's 2 quantities here. Sometimes people, and I'm showing you guys both methods. So I'm curious here. Let's see what you guys think. Anybody here rather do the single variable x or the double variables with x and y? Anybody? What would you rather use? 2 variables or 1 variable? 2. If you say 2 variables like the x and y, which we're working on, you got to have 2 equations. So you can't solve 2 variable problems with only 1 equation. So I want to kind of point that out to you, that if you like the x, y, there's no way you could do it without 2 equations. And here's the 2 equations that we have. Because you have to use the substitution method or the addition method, or graphing. But so 2 variables means 2 what? Equations. So just to remind you guys, I showed you both. 1 variable, 1 equation, 2 variables, 2 equations. So you're getting your good deal in your algebra here. Okay? A good deal in your algebra. Okay. Let's do the next one. Now let's try number 7, so you guys know. Number 7. The perimeter of a rectangle is 48. Is 48 meters. Let's think about it. If the width was doubled, And the length the length was increased by 11. And it's meters. The perimeter would be 84 meters. What are the dimensions? Okay. Okay, which shape are we talking about again? It's a rectangle, and you know because they told you. And then what are we referring to about the rectangle? The perimeter. So you can say P here is, again, 48. So I'll draw the same picture. Rectangle, we got a length, we got a width here. What do we know about this? That the perimeter is 48. Should we think of Vegas, or should we just write down what? All right, we'll do it all. P is 48, and then what else? 2L plus 2W. Well, perimeter is also 2L plus 2W. So we'll go through the logic. If P is 48 and P is 2L plus 2W, what that means is that 2L plus 2W is really what? 48. Okay, you guys okay with that? All right, what does the next sentence say? It says, if the width was doubled and the length was increased by 11. So what are you doing with this rectangle now? Right, here's the original rectangle. Has dimensions L and W. So what are they doing to this rectangle? They want to do what? Double the width. What does that mean to double the width? Anybody know? If I double my width, what does that look like? Multiply my width by what? 2. So I'm going to say 2 times W. Are you with me on this? And in a sense, isn't this a new width? Is that a new width? So yes, because they're going to double it. What are they going to do to the length? They're going to increase it by. If I was going to increase your salary, what does that word increase mean? Isn't that to add? So we're going to add what to the length? So I'm going to have to add 11 to the length. Isn't that in some ways a new what? A new length? Are you okay with that? What do you guys think? Is that okay? All right, here we go. What do they say is going to happen if we do this? We will get a new perimeter of what? 84. This perimeter, isn't that going to be new? So, let me write this down for you. How do I describe my new perimeter being 84? I'm going to have to double, if I find the perimeter of this new rectangle, the top length, isn't that L plus W, L plus 11 as well? Isn't this with 2W? So if I find the perimeter, aren't I adding all the dimensions here? Isn't that going to mean that I get what? 2 times what? 2W plus 2 times my what? L plus W. Isn't that going to give me my new what? Perimeter of 84? or this is my new situation. So in some ways, what they're doing to you is they have an old situation and a what? New situation. The old situation gave you one equation. The new gave you the what? Second equation. So we can simplify this new equation, by the way. How do you simplify? Right? You're going to have to multiply here and use the distributive property here. So just to let you guys know, this new equation is really 4w plus 2l plus 2w being 84. Or we can say, what is this? 2l plus what? 6w is 84. So here's my first equation.
L plus 11.
Oh, sorry. Thank you. I thought, okay. 2 errors in 1 hour. Oh, jeez. 22.
Better than 6, right?
It's better than 6. Getting better. Thank you. 4l plus 2l plus 22. Are we okay? Yeah. Okay, is 84. Translate my 22, and I get 4w plus 2l will be 84 minus 22. What's 84 minus 22? And I'm going to write it as 2l plus 4w. The reason I'm going to write it as 2l plus 4w is because I have my l here first. Okay, so can I change the order in which I add? The answer is yes. So I can say 4w plus 2l is 62, or 2l plus 4w is 62. So I'm going to point out to you, you got two now what? Two equations and two unknowns. Okay, here we go. Let's write down the equations. We have 2l plus 2w equals what? 48. The second one will be 2l plus what? 4w equals what? 62. So I'm just curious, what would you guys use to solve this system? What would you use? Probably, right? You use the addition method. So I'm going to say to you guys, go home tonight and use the what? Use your addition method. Formerly, we called that the elimination method, right? Okay. So you guys could go home and try that out and see what you get. But what I want to talk about now is one of my favorite topics. All right? Here's one of my favorite topics in word problems in beginning algebra. It is the dreaded, they're not really dreaded. It's the dreaded what? Mixture problems. Wow, mixture. Okay, so we're going to talk about mixture here. Do you guys know, mixture's kind of, when we talk about mixture problems in algebra, they're kind of general. There's a general mixture scenario. You're going to take two types of quantities. It's based on two types of quantities. Two types, so you can use probably what letters? X and what? And Y. So what are some things that you guys think you probably mix in your life? You mix drinks? I mean, we can. How about if we get 12 ounces of beer? How much alcohol is in beer? What percent of beer is alcohol? 6%. Okay, let's say you get 12 ounces of beer with 6% alcohol, and I'm going to mix it with my 4 ounces of wine and get wine. What percent of the wine is alcohol? Is it all alcohol? I don't know. I don't think so. Is it 14%? How come you guys know these things like that? 14%. I could ask you about a rectangle and triangle all day long. Angles, complements of it. You go, you know what? 14% of wine is alcohol and 6% of beer is alcohol. I'm going to make a wine mixture one day for you guys. Wine, not here, on the board. That's a mixture. That's a chemistry mixture problem. But we don't have to mix alcohol. What else can we mix?
Liquor.
That's alcohol. Liquor is alcohol. Alcohol is Vegas. Liquor is Vegas. I don't know. You could mix nuts. You like almonds and cashews? You get 5 pounds of almonds, 3 pounds of cashews. You could mix them. Can you mix ground beef with turkey? Ground turkey?
Chocolate and peanut butter.
Why would I mix ground beef with turkey? Ground turkey?
It defeats the healthy purpose.
It defeats?
I don't know.
What do you think? Anybody mix ground beef and turkey together?
You can, it's your choice.
I'm just curious. Has anybody made that choice? No?
Not necessarily.
Oh, I don't know. How about, will you mix ground beef with buffalo?
What about you mix ground beef with milk?
No.
Well, let's keep it simple. Let's keep it simple. You guys laugh at what I'm saying, but these are mixture problems. So you guys get a good sense of what do you mean mix? Yeah, I could get ground beef. Maybe I got ground beef that's 90% lean and 10% fat. What about buffalo? Why would you eat buffalo? It's a lean meat. It's high in protein, high in iron. The benefit of eating buffalo, ladies and gentlemen, just so you guys know why people do it. Anybody know why? Well, what's happening is this. More and more people are eating buffalo for one big reason. You know what they do to your ground beef, by the way? Anybody here going to go have anybody here have carne asada weekends and burger weekdays? People do. If you're a guy, I'm going to say to you as a guy, don't do that. Don't eat ground beef. Don't eat beef. Get rid of your carne asada weekend with beer. I'm not, some people do, all weekend long, carne asada and beer. And during the weekdays, they have their burgers.
Meat eaters are prone for heart attack.
Well, yeah. But it's, in my mind, there's another part of it that's pretty bad. You guys want to know what the other part is? They put hormones in the cows. They put estrogen in your cows so that the cows get bigger and fatter.
They do that
Same thing with chickens too.
Yes, they do it with chickens, but evidently with beef, it's a lot more serious because it's a bigger animal, I guess, and they use more of it. Anyway, I don't know all the details, but when it comes to beef, it's pretty much an issue. So if you ever sort of looked around and you might have noticed that men are starting to look more like women. Yeah. Men are looking more like women. And people are saying, what are you talking about? Their features are more feminine.
We're talking about American diet.
Yes, we are. Yes, we are. Yes, we are. Yes, we are. And you say, why is that an American diet? Because in America, that's what we do to our cows, and we love our cows. We love cows. Some of you guys, probably half of you are going to have a burger today. Okay? Love our cows. So what happens is with all the estrogen as a male, and as you keep living this way, eating a lot of beef, lot of beef, lot of beef, you're going to start crying one day because your thighs are too big. Because you start putting fat in areas where women traditionally put fat. You guys see what I'm saying? There's a new term. There's a very new term that's out now regarding to physical features of a man. I don't know if I should say it. I'm not going to say it. I can't say it. I'm on camera. It's a dirty word. Should we turn off the camera before I say the word?
Yeah. You did it to Japan, taking hormones to make the Japanese taller.
Well, it's interesting. Yeah, that did happen. Japanese, after World War II, you know, their features did change somewhat. And okay, so this is the mixture portion. What I want to focus on today is setting this up because what we did last week was solve systems. So hopefully on your homework, what you guys did, hopefully, was to solve systems by graphing, substitution, and then the what? The elimination method. Hopefully you guys worked on those skills because, you know, we're moving on. We're going to solve some more of these word problems. This is called mixture. Now, when you start working with mixture problems, you actually have two types. So you have what we call a type 1 and type 2. You got two types of variables. Okay, so you got two quantities, unknown quantities. So notice that, two unknown quantities. And very often, you know, this one says how many, there are 28 coins in all. How many, I'll say how many of each type. So how many are there of each type? We're going to have to look at the format of how to deal with the mixture. So I want to focus on setting up all the mixture problems and have you guys, again, focus on solving the problems. So let me ask you a question here. What are you guys mixing in this example? You're mixing what? Well, you're mixing coins. Is that true? So you're mixing coins. I want to say you're going to mix some coins together. That's a mixture problem. What two types are there? Dimes and what? Quarters. Is that right? So let me set this up for you. I'm going to say here you got a type 1 and a type 2 coin. What are they? Dimes. What else? Quarters. Okay? Yeah, let's do this over here. We got dimes and quarters here. We'll do it over here. I just erased. Spend all that time cleaning the whiteboard. Now it's all dirty and gone. I don't know what was on that rag. Anyway. Okay, well, too bad, I guess. Should we clean a little bit? Better have a nice clean board. Yeah, I don't know. You guys notice that when we work in word problems, you guys notice about mathematics that it's such a dynamic environment. Meaning we don't only talk about reading, or I should say, we don't even talk about just doing arithmetic. Okay, it's not just doing arithmetic and solving problems, which you guys could notice about really algebra and pre-algebra, the algebras. You learn a lot about reading, writing, and doing arithmetic, problem solving, critical thinking. Such a dynamic environment. Very different than a lot of your other courses. You know, a lot of courses you take, I won't mention any names. Take a course, maybe your test consists of what? Multiple choice questions? Guys, true and false, multiple choice, maybe you fill in the blank. Possibly, if they dare, an essay question. And when everybody freaks out. You guys know what I'm saying? Yeah. So it's kind of, in some ways, you know, compared to a math course, you have reading, you got writing, you got arithmetic, you have, models to consider, problem solving, critical thinking. So it's such a dynamic environment. So I make the claim to people that if you work on these concepts in a math and algebra course, you're setting the foundation for your success in every other course. Okay? And that's really kind of how it works. You're going to set that kind of foundation. Anyway, see, do we have our microphone on? Should we double check? Okay, Ashley takes out my headphones. And she doesn't put it back, just like a daughter. Do we have the volume on? Anybody here had any headphones on?
I do.
Let's see. Just double check with your headphones. All right. It's okay. All right, thank you. Let's just double check. We don't want to go through all the mixture problems and then what? There's no audio. Okay, let's see. Do we have? I think we have audio. Good. Thank you. Pass this back. Thank you. Okay, let's take a look at that. We're mixing coins. They're quarters and dimes. So let me set this up for you. Since there are two types, we're going to put type 1 column and a type 2 column. And in this situation, I'll say number. Okay. So can you guys tell me if your first type of is a dime, first type of coin, second type of coin is a quarter, what I'm going to say to you, number of, I'm going to say, let's let what? Let D be the number of dimes, and we're going to let Q be the number of quarters. Now remember, when you read a word problem or a mixture problem, how many times do you have to read it? Enough. So for everybody, that's a different value. So maybe you have to read it twice, 3 times, 4 times, 5, 10 times. And, you know, whatever that is, that's what it's going to be. So you get better the more you practice with. So you want to get a good feel with mixture problems because they're really not that hard. So how many dimes do you have again? We don't know. We're going to let D. D is the number of dimes. So this will be D. How many quarters? Q. Now when we read this over and over again, what do they say? That the sum of money, coins, amounting to $5.65 consists of dimes and quarters. If there are 28 coins in all, what do you think that means? D is the number of quarters, Q is the number of D is the number of dimes, Q is the number of quarters. How many coins do you guys have total? 28. So when I add my D with my Q, what do I get? 28. So I'm going to put my equation here that D plus Q equals what? 28. So you're going to identify the number of dimes and quarters or the number of each type being the total. You add them. And then I'm going to say to you, we're going to find the amount. You say, why am I going to find the amount? Well, in dollar situations and coin situations, you're going to have a certain amount of type 1 and a certain amount of what? Type 2. In dollars and coin situations. So if I know the amount of a dime, how much is a dime? Isn't that 0.10? How much is a quarter?
25.
Isn't that 0.25? If I want the amount just in dimes, what would I do with that value? Wouldn't I take the 0.10 times my what? D. Doesn't that give me how much I have just in dimes? And then don't I take the quarter, which is what? 0.25, multiply it with what? With Q. Doesn't that give me how much I have in quarters? And then what do I get? What do you think I get then? I should get, if I add how much in quarters, how much in dimes, I should get $5 and what? 65 cents. Okay? So I'm going to say this to you, that what this relationship gives you now is going to be, I'm going to put a note here for this last comment, that you get 0.10D plus 0.25 what? Q is $5.65 what? Cents. Now, do you guys remember on your homework, did you solve any systems that had decimals? Yeah, what do you do with that? How do you handle that when you have systems with decimals? Yeah, we're going to have to multiply every term by what number? By 100? Why 100? You want to move the decimal how many spaces? Why 2? Well, you'd have to move it 2 spaces for the 0.25, right? You'd have to move it 2 spaces for the what? 0.65. Now, maybe you don't have to move this 2 spaces, but by multiplying both sides or every term by 100, this is going to move this by 2 spaces as well. So you end up having here the relationship that 10d plus 25q becomes 565. So again here, this is your next equation. 10d plus 25q is 565. So ladies and gentlemen, this is the system that you're going to solve. And how are you going to solve this? By your favorite what? Method. Substitution. Probably not graphing. Substitution. Elimination. Okay, so here's the setup. You guys okay with that? I'll solve this one just for fun, briefly, just to kind of warm you up. But we want to focus on setting up the mixture problems. Okay, can I erase this? Yes?
I have a question. How did you get 28 though? Is it 10 and 25 plus 30?
There's 28 coins.
Oh.
So if there's D dimes, Q quarters, D plus Q would be 28. That's the number of coins. Okay, so I'm going to erase this. So let's do this briefly. D plus Q is 28. I think I'm going to multiply that first equation by negative 10. Okay, so if I multiply equation 1 by negative 10, tell me, don't I get what? I get negative 10D minus 10Q is negative 280 for my first equation. Second equation, 10D plus what? 25Q will be what? 565. I didn't do anything with that. By the addition method, I get 15Q, and I get, I think that's 285, right? Sure do. By the addition method. Divide both sides by 15, and I'll get Q to be 19. There's 19 quarters. Excuse me? Yeah, what did I do? I multiplied that first equation by negative 10 because I'm using the addition method. Exactly. What goes away if this is negative 10, negative 10, negative 10? If I use the addition method, my D's go away. So I got my Q's now. So this says I have 19 what? Quarters. Now remember, I said you're going to solve this by what? By your favorite method. This is what you spent your weekend doing. Wasn't at the Halloween party, right? Solve the system. I use the addition method, also known as elimination, to eliminate my D variable by multiplying the first one by negative 10. And I got 19 quarters. Now, how many dimes? By back substitution, what do you guys do? How many dimes? Plug in Q as what? 19. What do you get for the dimes? We get D plus 19 is 28. Translate the 19. So D will be 28 minus 19. Or D is going to be what? 9. So like I said, this is what we worked on last week, solving the systems. This week, or the end of last week, and then today, we're looking at the mixture problems, how to actually use the tools you learned. And that's really the vital, because, you know, you're not just learning a method for fun, you're going to learn the method so that you could do something with it. And that's the most important thing. Yes?
So where it says 10D plus 25Q, then it's negative 10D?
Where it says 10D plus 25Q, here, nothing's negative. It's negative up here.
So then why did you subtract 10 plus 25?
Because it's a negative 10.
You're adding here by the addition method. The left sides together equals the right side. So it's 15Q is 285.
All right, I get
Okay? We use the addition method here.
So on the top, there, minus 10, minus 10, 10D, minus 10Q, minus 280, you multiply all those by 10.
Not by 10, negative 10.
Negative 10.
Why did I do that? Isn't that my first equation? We multiply by negative 10? Yes.
How did you get, for the first equation, how did you get negative 10Q? Where did you get that to?
Oh, yeah, you did addition method.
Huh?
So, you did addition method.
No, I know what addition you did, but how did you put,
That was his question. You want to ask him?
We multiply everything by negative 10. The D plus Q equals 20 times negative 10.
Negative 10 times this. Negative 10 times this. Negative 10 times this. So, what method are we using again? Elimination. Oh, you guys had some homework to do. It's okay, you can do it next semester. Let's do it next semester. That'll only be strike 2. You got how many strikes? You got 3. Just try it next semester. So negative 10 times D, negative 10 times Q, negative 10 times 280 becomes what? This equation, you say, why do I want that equation? I'm using the addition method. Aren't these values opposites? So like I said, my focus today is not on the solve, because that was last week's focus. Today is on the what? Setting up your mixture problem. Okay, so we're going to work on the setup, but yeah, that's how you do it. Okay, now if you don't want the addition method, what could you use? Substitution method. Okay. So, okay, let's take a look at another problem. This is a coin problem, by the way. There's no difference between a coin problem and, let's say, a bill problem. Or let's look at this. Let's look at number 14 here. We'll look at a ticket problem. So number 14, let's kind of paraphrase what 14 says to you. 14 will say, Ron and Kathy are ticket sellers at their class play. Ron handles student tickets. So I'll say, Ron handles what? Student tickets. Okay, he handles student tickets and they sell for $3. This is what it's saying. We also have who? Kathy. Kathy handles what? Kathy handles adult tickets. And they sell for $6 and what? 50 cents. Okay, if the total income, here's the question. If the total income for 27 tickets was $105.50, comma, how many tickets did each person sell? Okay, so this is number 14. We're going to set this concept up in the same way. Compare this to your coin situation. Okay, this mixture has two types of what? Do you guys know? What are they mixing here? Tickets. Good. So you got two types of tickets. So you have two types of tickets that you're mixing. So let's put that here. What are the tickets? You got adult tickets and what? Child tickets. So type 1 is where you have the adult tickets. Type 2, you have the what? Child tickets. So notice this is two types. What's the question, by the way? Do you guys know what the question is?
How many tickets?
How many tickets of what? Each type did you sell? Very often, what they're asking is your variables. So you got two types of tickets. Adult and what? And child. Is that true? So type 1, we're going to call these are the adult tickets. And type 2, we have the child tickets. So what I want to say here, let's write it down here. Let A represent what? Let A represent the adult tickets. And we're going to let C represent what? Represent the child tickets. Now we're talking about number of tickets, okay? This is the number of tickets. So we have A for adult, C for what? Child. We don't know those quantities. That's what they're asking us. How many did they sell for each person sell in terms of Kathy and Ron? So what is the total if I add those two? How many tickets are there, period, here? How many? How do you know? They're telling you there's 27 tickets. So the sum here will be what? 27. And just in terms of the number of tickets. So you have here A plus C equals what? 27. It's the number of tickets. And then we're going to have to start to talk about the what? The amount. Because what did they give us? What is this? What does this $105.50 represent? That's the total value in terms of dollars, right? Bless you. Okay, so let's think about this, right? How much is an adult ticket? $6.50. Okay. How much is a child ticket? $3. So the rate at $6.50 times the number of adult tickets, doesn't that give me, if I write down, $6.50 times the number of adult tickets, doesn't that give me the dollar amount in terms of adult tickets? And then what's $3 times the number of child tickets going to give me? Right? $3 times C. Doesn't that give me the amount in terms of the child tickets? And then what happens when I add these? What should that total be? Huh? 105 point what? 50. So take a look at this. Let me write this down. This is money, I realize it. But if I write down, I'll put it down here. Let's note. The second equation, can I just write 6.5a plus 3c? Isn't that equal 105 point what? 50? Or 105.5? What I'm saying to you is, do I have to put the extra zero there? Do I?
No.
No. Can I if I wanted? Sure. Does that really change anything? Well, not necessarily unless I'm consistent. Now, this is a second equation we're going to use to solve in our system. The problem is it has a decimal. So we're going to have to fix this. Is that right? So when we have a decimal that requires us to fix this, what do? You got to take this decimal point, and what are we really doing? Multiplying every value here by 10 or 100 or 1,000 or 10,000. We're going to have to move our decimal. Is that right? So how many spaces should I move this decimal till I get a nice whole number? 2 spaces or 1? You guys know I can move it 2 spaces, but do I have to? I can move this 2 spaces, but do I have to? No. Because don't you have a nice whole number here by only moving it one space? Like you have over here? Is that true? Isn't 65A a nice whole number? Isn't 105 with another 5, which is 1055, a nice whole number? If I move these decimals one space, I have to do what? Move that one space. So move it one space, and what do you get? 30, good. Don't forget to do that. I can move it two spaces. If I do move it two spaces, though, I get 650A, and I get over here, if I move two spaces, 10550, that's 10,550. If I move this two spaces, that's now what? 300C. So this is moving the decimal two spaces, this is one space. Which would you rather use when you solve a system? The one space, why? Smaller numbers. So here's where the critical thinking comes in for you. Stop and think about, if you're going to do this form of arithmetic, what would be easier for you to do? The smaller numbers are the what? Larger numbers. That's why you care about moving decimals. And how many spaces? So this would now be 1055, okay? Again, you now have what? Two equations and two what? Unknowns to solve, A and C. Okay? And this is number, what is this number again? 14. This is 14. And to let you guys know, let's see, the child tickets, they get 20 tickets. In other words, I believe here, if you do the work, if you solve this system, by solving the system, they found C to be what? 20. Now, note, if C is 20, right, they solved this system by either elimination, okay, or substitution. So let's note, A plus C is what? 27. They solved this by one of those methods. They found that there's 20 child tickets that were sold. How do I find the number of adult tickets? You get A plus 20 is what? 27. So you get A plus 20 is 27. Translate your 20. You get A is 27 minus 20. Oh, we get A is the value what? 7. So the adult sells how many tickets? Or the adult is 7 tickets, 20 tickets for the child. Okay, so you can mix coin together, and you could even mix different types of tickets. We're only mixing two things. Okay, you guys okay with this one? Okay, anybody have any questions on this one?
So the answer is 87.
How do you get, that's for you to do for homework. That's right, that was last week's. You guys have to keep this up. You can't review everything every week. It's time to move on. So that's for you to do, or it was for you to do for your homework. So you tell me how we get 20. That's what you're going to be tested on. So you got to keep up to date, otherwise you'll be left behind. Okay? Homework's important. You got to get on it. Besides that, anybody have any questions on setting that up? Because this is where we're at now.
Do you have to make a chart to order set up the problems?
Some people do. Some people find the chart to be what? Helpful. Okay, so some people find this chart to be helpful. Do I have to do it? Personally, no, I could do it without it. Because as long as you know the model of mixture, and you say, well, how do I learn this mixture model? By going through coin problems, ticket problems, dollar problems, by doing all that. Okay, there's only one way to learn, and that's through what? Through practice. The note? If C is the value, this note right here? Oh, I'll keep it? Yeah. Okay. Yeah, there's no, you know, it's kind of funny. There's no magic here. A lot of times people go, oh, there's magic. You were born with that magic. No, it's not born at all. It's about simply doing what? It's about getting your hands dirty, working on those problems. It's about studying the problems. Math courses are very different. We've got some work to do. Here we go. It's okay.
It's 11:50. We got 10 minutes.
You got a lot of time. So yeah, you really want to, you really got to think of that. But like I said, for me, you know, it just enabled me to do what?
More math.
To read the math book. And in the end, that did me, you know, that was actually a blessing, not a curse. Isn't that ironic? I think that's some amazing irony. I mean, sometimes I think about that and like, wow, it just dawned on me the other day. You know, talking to my calculus class because they got to remember a lot of other things, and you know, so it's fascinating. Well, let's take a look at this. Number 16 is we have Marty. Evidently, Marty, number 16. Marty has an inheritance. Marty has how much money? She has $60,000 in that first sentence. The second sentence is that she's investing part, so she invests part in account 1 that pays, how much does that pay? 11%. And that's interest. And what else does she do? The rest is invested in account 2. That pays 12%. Her total interest on both investments is $6,900. How much did she invest in each account? Okay, so this time we have a person who's investing what? Money. Is that true? So she's investing some money. So again, if you like, we got type 1 account, and we have what? Type 2 account. Okay? So you got type 1 and you got type 2. The first account pays how much interest? It's 11%. And the second account pays what? 12%. So notice what they're asking you. So it's saying how much money did she invest in each account? You guys don't know that. There's 2 accounts. So I'm going to say let X be the amount invested in account 1. And we're going to let Y be the amount invested in account number what? 2. So you got X and you got Y. So you got X as the amount in account 1. Y is in account 2. How much money does she have total in terms of being invested? You got to read this and you say, well, how many times? You got to read it enough. So how much is she investing? What do you think? How much money? What do you think? $60,000. Good. So what does this mean for you? That first equation is going to be, let's write it, we could write it right here. That X plus Y is what? 60,000. We may not have enough space there. So the amount in account 1, I guess I'll write it down here. The amount in account 1 plus the amount in account 2 should be the total that she invests. Is that right? So you have X plus Y is what? Is 60,000. Okay? And then, what do we know about these rates? Got 11% account and what? 12%. So, here we go. So this is the dollar amount. Okay, and we'll call this the interest. So the dollar amount row and the interest row. So how do you get your interest, or what's the simple interest formula? It's at 11% times the what? The amount invested. So 11% of X dollars, 11% X, and then you have what? 12% of what? Of Y dollars. So that's 12% Y. So she has interest in account 1, interest in account 2. What's her total interest? 6,900. Good. You guys see how easy that is? Okay, so let me write down, how do you represent 11% anyway? Isn't that point what? 0.11. So you get 0.11 X plus 0.12 what? 0.12 Y. What does that equal? 6,900. So what do you do with your decimals? You guys know? What do you do with this? Multiply every, remember, you fixed these last week. How do we fix them? Multiply by 100. Okay, don't forget to multiply this by what? By 100. If you do, don't you move this decimal 2 spaces already as well? So you fill that in with what? A couple of zeros. So when we fix this one, we have 11x plus 12y is 6900 with a couple of more zeros. So we got our first equation, and we have our what? Second equation. And you'd solve this by your favorite what? Method, whatever that is. Addition method or what? Elimination probably. Just like last week. Okay, so these are mixture problems. Let's get to one of my favorite mixture problems. Let's say this, number 21. Let's try this mixture problem. So remember, we're going to set that up. You're going to have to solve it.
That's it? That was our answer?
No.
Oh, okay.
You should not have left that class. Okay, on a test, I look for these two equations, then I look for the solution. You're going to find that x is 30,000 when you solve this. You'll also find that y is what? 30,000. Okay? Now let's stop and think about this. This is a chemistry mixture problem. And I like this because, I mean, here's how it works. Let's do number... Oh, actually, I think I want to do number 21. Yeah, here we go. Here's the question. How many liters, this is a little different. How many liters of a 30% alcohol solution must be mixed with 90 liters of a 60% solution, of a 60% alcohol solution. To get a 40% alcohol solution. Okay, so believe it or not, this is done very, very similarly. Okay, this is a mixture problem. All of these are mixture problems. You need to go home and try these out. Check your solution. But let me say this to you. Don't let the fact that these are alcohol solution problems scare you, because some people do. You know, some people let that really intimidate them. So I want to say to you guys, let's note what's really happening. I'll put a note here. Is anybody, where are the drinkers in the room? Okay, good. I'm just curious. Good. How much alcohol is in beer? Okay, what do you think? Give me a value.
Heineken, 9%.
What is it?
Heineken, 9%.
Good. We got a beer drinker. You know, you got 9% what? Alcohol. You okay with that? Is in beer. So here's your beer. Oh, I don't know. How many ounces of beer do you have? 12 ounces. Let's just say that. So what I want to say is you have an associated amount, right, of beer. 12 ounces. Where 9% is what? Alcohol. So I'm going to say, here's my beer, 12 ounces. And you know it has 9% what? Alcohol. What does that mean to you? 9% alcohol, 91% what? Non-alcohol, whatever that is. Okay, who drinks wine? Where are the wine drinkers in the room? Okay, good. I'm not saying you're drinking a bottle. Alcohol. What do you guys think? How much alcohol is in wine?
3%.
Is it 3%?
Yeah.
I don't know. How much is it? Is it 12%? Is it? Huh? Oh, you see, you guys know your alcohol. Thank you. I knew it. I knew it. 12% what? Alcohol. And when you have a glass of wine, do you have 12 ounces for that glass of wine? No. What do you usually have, maybe? Maybe 4 ounces. You guys with me on that? The point I'm making here is this. You have a beer quantity and you have a wine quantity. It doesn't have to be the same quantity. And notice both of them have different percent alcohol. Right? What's the worst thing you could drink, by the way?
Vodka.
In terms of okay, vodka. I don't know if it is or not. What percent of vodka is alcohol?
I'll say 50.
Where are the drinkers in the room? It's not drinking. What is it? Is it 40%? I've heard, I don't really know, that it's 40% alcohol. You with me on this? All right, here's what I'm going to say to you. Here's what I want to say. What happens if we mix our beer and our wine? Do you guys see what I'm saying? We're going to mix beer and wine together. What do we get? We get wine. We get wine. So let's notice this. If I'm going to talk about my wine mixture, I want to notice a couple of things. Let's note. What's the quantity of wine when I mix my beer and wine? What do we get? For wine, what do we get? How much wine do I have? Anybody know? It's the 12 ounces plus my what? My 4 ounces. What does that give me? That gives me a total of what? 16 ounces. You guys okay with that? So my mixture yields 16 ounces. I'll put in a cup that looks like this. There's 16 ounces of wine there because it's 12 and 4 gives you 16. The question I have, though, is what percent do we have alcohol? It is not going to be 9%. It's not going to be 12%. It'll be exactly something in the middle of that. You with me on this? So my wine mixture has a certain percent alcohol, and there's 16 ounces. This is the essence of mixture problems. It's so funny that so many people see a mixture problem and they run for the hills. But yet if they had beer or wine, what do? They jump on it. It's the same concept. Imagine here, what? You got a 30% alcohol solution? That's not even vodka. I don't know what it is. And then you have what? It must be mixed with 90 liters of what? 60%? I think that's jet fuel. I don't know what that is. That'll make you go blind. You okay with that?
I think it's 90%. That would make it really good.
And they want a solution that's vodka related, 40%. Okay, here we go. You guys ready? Let's set this up. You got type 1. And you got what? Type 2, and you got a total. You're going to do the following. You're going to tell me about the quantity. In other words, just the quantity, the overall quantity. How many liters? Do you guys know how many liters? No. So call that what? X. We have X liters of that first type of alcohol. This is the 30% mixture. And they're going to mix this with what? 90 liters. So we're going to call that what? 90 liters is going to be mixed with what percent is that? Wow, 60% alcohol. You with me on this? So let me erase this here. It's not beer. The first item is 30% alcohol. I don't know really how much, because that's what they're saying. How many? X. It's not wine, but it's a mixture of, what percent is that? 60% alcohol. And how much is here? 90 liters. It's not ounces. This will be 90 liters. So notice, if I add the X with the 90, I already know that gives me X plus what? 90. I already know that. That's in terms of the quantity in liters. But what I'm going to do is I'm going to set up two equations. I'm going to call this actually what? Y. So what this says to me is that first equation is going to be X plus 90 equals Y. So I'm going to write that down, my first equation. X plus 90 is Y. Now let's look at the quantity in terms of liters and how much pure what? Alcohol. So I'm going to relate the pure alcohol here. Now, did you guys know in the case of beer, how many ounces did we have? 12 ounces? In which, what did we say was it 9%?
Yeah.
All right. 9% of 12 is a value. That's what that means, is that that much ounces is just pure alcohol. It was mixed. Same thing with wine. 4%, or 4 ounces times what? 12% was it? We said. So that's going to give you a certain amount that's pure alcohol. We're doing that here, meaning with the first mixture, 30% of X is just pure alcohol. So you're going to write down that 30% of X. That'll give you pure alcohol. 60% of how many liters? 60% of 90 liters, that's times, like this is times. 60% of 90 liters is going to be pure alcohol. Okay, so the second type that they told us how much liters, 60% of 90. And they want, in the end, what? A 40% alcohol solution. So they want this to be 40%. Well, that's going to be 40% of what? Of Y. Exactly. So the second equation, let's note down here. 30% X plus 60% of 90, we have to yield 40% of Y. That's the trick here for doing mixture problems with two variables. I know this is X plus 90. You're going to call it Y. Call that Y. So that this equation now will be 0.3x plus 0.6 times 90. which is 0.4y. What's 0.6 times 90? Is that 54?
Yeah.
So ladies and gentlemen, this is going to be what? 54. So here we go. The second equation will be 0.3x plus what? 54 is going to give us 0.4 what? Y. Do we have to fix this? Yes. Move the decimal what? One space. If I move these decimals one space, don't forget to move this decimal. People always forget that. This will be one space. You got a 0 now. So you got 3x plus 540 is 4y. And this is what you get for your second equation. This is your first equation. I might use what method here? Substitution. You're right. I might use substitution. And in fact, 21 has an answer. If we're looking back at the book, sorry, not back of the book, at the worksheet, this is word problems 2. 21 says that there's 180 liters. So they find that X will be 180 liters. So if I have 180 liters of type 1 solution, what's the total I'm going to have, by the way, for the mixture? Isn't that 180 plus 90, which gives you what? 270. So you're going to have 180 liters, you know, of that 30% alcohol. So maybe on a test, I'm not going to use this. I'll talk about real alcohol. And say, what do you mean real alcohol? Beer, wine, vodka. Would that be more helpful to you?
It's better
It will.
to use Puerto Rican rum.
Oh, is it?
150%.
How could it be 150%? 150%? I got to look into this. It can't be 150%. Rum?
Yeah, no, the rum that comes from
Check it out.
I'm going to have to take a look, but I got to warn you guys, there's no way you can exceed 100%, can you?
No, you'll die.
No, there's two things going on. If you have a mixture, like here, this, at best, this is 100% alcohol, pure alcohol. Be careful, could it be more than 100%?
Yes.
No, it can't be. If this is pure alcohol, it can't exceed 100%. It's like if I said I'm going to, well, never, let's not go that way. 100% alcohol. Do you guys know gasoline or jet fuel? What percent? I'm not a drinker. In Russia, I hear they drink their jet fuel. Russia has a drinking problem, ladies and gentlemen.
Even Germany too.
Russians drink too much. In fact, there's a lot of issues with that. But they drink pure jet fuel. I'm just saying, what percent of that is alcohol?
Like 100%.
Is that 100%?
Yeah, it is.
I don't know.
It's strong.
You can't go more than 100. And I think you actually die if you actually have a certain percentage of alcohol.
Shut down your heart.
Anyway, we'll see you guys tomorrow. So avoid you know who. Okay?
You'll see him. He's coming in right now.